Welcome to our class. So today we will talk about the error detection in the system code. When you call a system code, if there's a problem happens during the system code, how your kernel deal with this, and how you get this message from your kernel. So will be a good topic and an important topic because not every time you call a system code can get the successful executions by your kernel. So that might be any issue. For example, you try to connect to a network and the network is just get interrupt because of there's a couple different problem, right? For example, you don't have a reliable network or the server you try to connect uh, has already achieved the maximum connection the server is. So there's a lot of problem can be. So when you call a system call, for example, you use the system call to try to connect to a server, and in the end, you find that you cannot connect to it. How you check it? How you check it it's in your program. So in your program, you probably also need to deal with these errors, right? If you cannot connect it, maybe you want to try to reconnect it, or you just like send a message, okay, I cannot connect for you this time, so please run me again. So you can have a different way to deal with this. Okay, so in C, how to get this message, I think it's really important topic. Actually, how to detect an error message, there's a two step to detect error message. The first step is about checking the return value. The return value is extremely useful. So step one, check the return value. So in any C documents for system code or library function is true. System code library function, you should check the documents. The document will show you, okay, if this open, this system code return a new file descriptor means it's successful be wrong. So if it's successful, it should return a new file descriptor. Otherwise, it's return -1, which means it's failed. So in this case, you will see -1. If you call a system call and return value is -1, means this failed. This system call is failed. Okay, so this is the first step. Not just in system code, it's happened in your library function. Also, why I say is you need to check the document because it's different for every system code. It's different for every library function. So sometimes you will see return 0 means fail. Sometimes you will see return -1 is fail. So you don't know. You don't know what's the actual value means the error if you don't check the document. So good behavior, good programmer behavior, check the document before you use it. You can use man here. For example, you can say man open. Then your Linux manual will like show you how to use this system code, what's the return type, what's the error value should be. Okay, so this is the first step to check does its successful be wrong on the system code or library function. This is the first step. So now I know when I see -1, -1, I know, okay, there's some problem in the open system code, but I don't know what the problem is. I just say, okay, there's a problem, but I don't know how to solve it because I cannot figure out what the problem is. Okay, you just tell me you fail. Why? You need to tell me the reason, right? So okay, so in this case, actually, there's another step we should take care. So let's talk about step 2. Okay, the step 2, if you really care what's the error message you want to do, first of all, you might need to include a special library function called error, error number. Okay, so let me make it bigger. ERRNO.h. Okay, so you need to include this special header file because every error details already defined in this header file. Okay, so after you use this header file, which means you can get the basic information of your of this error message, then try to use a variable defined in this error file is called error number, ERR, same one, ERRNO, try to use it. So we can see, okay, if FD equal -1 means something happened, right? We can say, okay, let's try to check the ERRNO equal some error message. For example, we can check is it the interrupt, some like interrupt. We can do it, okay? Then we can try to, for example, reopen or try to just like send some message, printf, and so on. So this is how you, the second step to deal with the error message. First step, check the return value. First step, check the return value. Second step, if error happened, check what error is by using error number.h and use a variable name called error number. If error number equal some error message, means this means some like they try to like tell you what the error message is. So in this case, you understand when kernel find that the kernel cannot execute the system code successfully, correctly, the kernel will automatically figure out, okay, what's the problem, and try to put the status, what the problem is, into this special variable. Okay, so it's try to put the information in the environment setting as this variable. So it's try to use this very special term to store the error message. Then you can get this error message by include this error number.h and use error number to check what's the value inside it, and you will figure out, okay, what the problem is. So this is how your system, how your kernel to manage the error message in your system code to allow the user program to understand, to check what the message is. But there's a two-step. First one, you need to know, oh, here there's a problem. Okay, there's a problem happen. Then you check what the problem is. This is how your error detection should be in your user program. Okay. So this is a short lecture, just the key, how to detect the error message, how to detect the, how to do the error detection in your system code. First step, check the return value of your system code. If the return value means fail, for example, for open, take open as an example, if it's -1, -1 means it's fail, then you check the special term, error number, ERRNO, check it, what's the error it is. You can use it to compare the value of like other system code. Of course, if a return value means success, if a return value means success, for example, you got 0 from open, or you got like 2 from open, it's fine. If it's success, don't check the error message. Why? Because the error message might be the error for previous system code. It might not be the current system code. Okay, so the kernel try to update this variable, this special variable, if error happened. If error doesn't happen, the kernel won't do anything for it. So this variable might be still stored the error message for previous system code. So again, there's two steps. Before the first step, you check the return value. Don't check the error message. Okay, you check the error message only when you see the return value equal to fail of the system code. You got idea? Okay, so I hope you enjoyed today's lecture. It's a short lecture. I hope you understand how to use this return value to make a decision which to whether the error happened or not. And you know how to use this error number, this special variable to check the error status. Okay, so hope you enjoyed today's lecture. See you next time. Error detection is awesome.